You can find a link to the carbon dioxide problem report in the description below. Good morning, I'm Ed Evans, and I'm going to share a video, and I base the resources for this video on James Speth's book, They Knew. Who knew what? What did they know? United States presidents knew about the new climate change, they knew what was causing it, and they deceived us for all those years, for over a generation. United States presidents deceived us. Here's a robotic reading and another introduction. I know it's all boring, but you know where to come when you want to find the facts.
The carbon dioxide problem, implications for policy in the management of energy and other resources. A report to the Council on Environmental Quality. July 1979. George M. Woodwell, Gordon J. MacDonald, Roger Revelle, and C. David Keeling. The CO2 problem. Man is setting in motion a series of events that seem certain to cause a significant warming of world climates over the next decades unless mitigating steps are taken immediately. The cause is the accumulation of CO2 and other heat-absorbing gases in the atmosphere. The result is expected to be a differential warming of the atmosphere near the Earth's surface, a warming that will probably be conspicuous within the next 20 years. If the trend is allowed to continue, climatic zones will shift, and agriculture will be displaced. Such a series of changes would have far-reaching implications for human welfare in an ever more crowded world, would threaten the stability of food supplies, and would present a further set of intractable problems to organized societies. The best estimates suggest that there would be the least change in temperature in the tropics, but polar regions would grow substantially warmer. With sufficient high-latitude warming, the ice cap in the western part of the Antarctic continent could disappear in a period as short as 2 centuries, causing a 20-foot rise in sea level with resulting inundation of low-lying coastal zones. Enlightened policies in the management of fossil fuels and forests can delay or avoid these changes, but the time for implementing the policies is fast passing. The carbon dioxide content of the atmosphere is increasing at an annual rate that is now about 1.5 ppm in a background of about 333 ppm. The increase since 1860 is at least 40 ppm, possibly as much as 70 ppm. Precise data on the increase are available since 1958 when monitoring stations were established on Mauna Loa in the Hawaiian Islands, at the South Pole, and intermittent sampling was intensified elsewhere. The data show that the rate of increase is accelerating as the world use of fossil fuels increases. The rates of both are between 3 and 4% annually. This rate means that in each period of between 18 and 23 years approximately twice as much CO2 accumulates in the atmosphere as accumulated in the previous period. The problem is that CO2, in contrast to the major atmospheric components O2 and N2, absorbs infrared radiation, which is the principal outgoing radiation from the Earth's surface to outer space. Over any extended period, the infrared radiation emanating from the top of the atmosphere must balance the solar radiation absorbed by the atmosphere, the oceans, and the Earth's surface. The increase in the CO2 in the atmosphere can thus be expected to result in a rise in the surface temperature until the outgoing infrared radiation comes into balance with the absorbed solar radiation. The extent of the heating that will result depends on many factors and is difficult to predict, but there is reasonable agreement that it will occur and will be conspicuous before the end of this century. The changes in climate that will follow such an increase in temperature are also elusive. The experience from models of world climate is that the warming may be as much as an average of 2 to 3 degrees Celsius for a doubling of the CO2 content of the atmosphere, and that the warming will be greater by a factor of 3 or 4 near the poles and less in the tropics. There appear to be very few clear advantages for man in such short-term alterations in climate. The displacement of agriculture in a world constantly threatened by hunger would alone constitute an extremely serious international disruption within the lifetimes of those now living. The warming of the Antarctic could, according to some estimates, result in the disappearance of the West Antarctic ice sheet in a period as short as 200 years. Such a process could be started by an increase in summer temperature in the Antarctic Ocean surface waters of 5 degrees Celsius. Such an increase could occur in 50 to 75 years if current trends continue. A complete disappearance of the West Antarctic ice sheet would raise sea level by as much as 20 feet worldwide. By itself, the increase in atmospheric CO2 would probably be beneficial for agriculture because the added CO2 will act as a fertilizer for crop plants. But there is little basis for hope that a decades-long warming of the Earth will result in benefit for man. Certain areas now suitable for agriculture will become arid, others, now limited by short season, will become arable. The cause of the current increase in CO2 in air is the oxidation of carbon compounds worldwide. Fossil fuels are one, probably the major, source. The harvest of forests and the decay of soil humus are thought by some to be an equally important contemporary source, although its importance will decline with time. The important fact, however, is that the atmosphere is a comparatively small reservoir. It contains about 700 x 1015 g of C. The biota is variously estimated as containing about 800 x 1015 g, the humus, 1000 to 3000 x 1015 g, and the oceanic water nearly 40,000 x 1015 g. Reserves of fossil fuels contain at least 5,000 x 1015 g. The current use of fossil fuels is releasing 5 to 6 x 1015 g C annually, and the biota and humus are probably contributing an amount of similar order of magnitude. The combustion of fossil fuels has the potential for a greatly increased rate of release over the next years. The most remarkable aspect of the current circumstance is the fact that the CO2 content of the air is as stable as it is. Clearly, a shift in any of these carbon pools or rates of transfer has the potential for altering the CO2 content of the atmosphere. This series of shifts is already underway. For this reason, if for no other, the industrialized nations, now scrambling for policies in the management of increasingly scarce supplies of energy, should be considering the implications of their policies for the CO2 balance of the atmosphere. If we wait to prove that the climate is warming before we take steps to alleviate the CO2 buildup, the effects will be well underway and still more difficult to control. The Earth will be committed to appreciable changes in climate with unpredictable consequences. The potential disruptions are sufficiently great to warrant the incorporation of the CO2 problem into all considerations of policy in the development of energy. 2. The elements of policy in management of the world CO2 problem. The challenge is obviously worldwide. The problem cannot be resolved by one nation acting alone. However, the U.S. provides leadership on many international issues. The elements of policy proposed here in outline are for the U.S. They apply as well to the world. 1. Acknowledgement of the problem. The CO2 problem is one of the most important contemporary environmental problems, is a direct product of industrialization, threatens the stability of climates worldwide and therefore the stability of all nations, and can be controlled. Steps toward control are necessary now and should be a part of the national policy in management of sources of energy. 2. Conservation of fossil fuels. The first element of any policy that offers the hope of being effective is conservation. Limitation of the rate of exploitation of fuels is possible. The rate is controlled currently by price, taxation, and regulation. It can be controlled as a matter of policy. All actions of government should be reviewed to determine effects on the total use of carbon-based fuels. 3. Choice of fossil fuels. The choice of fossil fuels and the use made of them bears heavily on the amount of CO2 released to produce a unit of energy. The production and consumption of liquid or gaseous fuels from coal, synthetic fuels, for instance, is estimated to release 3.4 x 1015 g C per 100 quads, 1015 BTU, of energy as opposed to 1.45 x 1015 g C for an equivalent amount of energy from natural gas. The difference in CO2 released is a factor of 2.3 times greater for the coal route to gas than by using natural gas alone. If the coal is burned directly, use of 100 quads of energy releases 2.5 x 1015 g C. These are merely examples. Details appear in Table 1, below. Table 1. Carbon released in CO2 per 100 quads of energy released as heat. 1 quad equals 1015 BTU. From McDonald, 1978. Carbon. Fuel. In 1015 g. Oil. 2.0. Gas. 1.45. Coal. 2.5. Coal, converted to gas or oil, synthetic fuels. 3.4. 4. Reforestation. It seems elementary that we have reached the point worldwide where the CO2 problem alone dictates a need to balance the harvest and other transformations of forest with some other storage of carbon. The regrowth of forests is the obvious solution. Total respiration, including fires, should be less than or equal to, but not more than, total photosynthesis on a regional and worldwide basis. There are many additional advantages in such a program, quite apart from the advantages gleaned from wise management of the CO2 problem. It is our conviction that an appropriate reaction to the mounting worldwide squeeze on supplies of energy requires consideration of the CO2 problem as an intrinsic part of any proposed policy on energy. G. M. Woodwell is director of the Ecosystems Center of the Marine Biological Laboratory and immediate past president of the Ecological Society of America. Gordon J. McDonald is Henry R. Luce Professor of Environmental Studies, Dartmouth College, Hanover, New Hampshire. A member of the National Academy of Sciences, he served on the Council on Environmental Quality, Washington, D.C. Roger Revelle, a member of the National Academy of Sciences, is currently at the University of California at San Diego. He was for 11 years Richard Saltonstall Professor of Population Policy and Director of the Harvard Center for Population Studies. Charles David Keeling is Professor of Oceanography, Scripps Institute of Oceanography, La Jolla, California. Selected references: Bolin, B., and W. Bischoff, 1970, Variations of the Carbon Dioxide Content of the Atmosphere in the Northern Hemisphere, Tellus 2, 431-442. Atmospheric Carbon Dioxide Variations at the South Pole, 1976a, Tellus 28, 552-564. Keeling, C.D. et al., 1976b, Atmospheric Carbon Dioxide Variations at Mauna Loa Observatory, Hawaii, Tellus 28, 538-551. Kellogg, W.W., 1978, Is Mankind Warming the Earth? Bulletin of the Atomic Scientists, February, 11-19. Lamb, H., 1977, Climate, Present, Past and Future, Volume 2, Methuen, London. MacDonald, G.J.F., 1978, An Overview of the Impact of Carbon Dioxide on Climate, MITRE Corporation, McLean, Virginia, 22102. Manabe, S., and R. Wetherald, 1975, The Effect of Doubling the CO2 Concentration on the Climate of a General Circulation Model, Jour, Atmosphere Sciences 32, 3-15. Ravel, R., and W., Monk, 1977, The Carbon Dioxide Cycle and the Biosphere in Energy and Climate, Report of the Geophysics Study Committee, National Academy of Sciences, Washington, D.C. Ravel, R., and H. Seuss, 1957, Tellus 9, 18-27. SCEP 1970, Man's Impact on the Global Environment, Assessment and Recommendations for Action, in Study of Critical Environmental Problems, Cambridge, MIT Press. SMIC 1971, Inadvertent Climate Modification, Report of the Study of Man's Impact on Climate, SMIC, Cambridge, MIT Press, 319 pp. Woodwell, G.M. and E.V. Pecan, eds. 1973, Carbon in the Biosphere USAC, Technical Information Center, Springfield, Virginia, 392 pp. Woodwell, G.M., R.H. Whitaker, W.A. Reiners, G.E. Likens, C.C. Delwich, and D.B. Botkin, 1978, The Biota and the World Carbon Budget, Science 199, 141-146.